Today we're learning about the transformations of different graphs and equations. So we're specifically going to be working with function notation, which we're going to learn about further in just a second, and absolute value equations. So I'm going to zoom in a little bit on this. So these are the two columns we're going to fill out on this chart today, but as we continue through different chapters, we will fill out additional columns. Okay. This first parent function means like your simplest functions. The simplest way you can write in function notation is f of x. So that's function notation. The parent function or absolute value, or the simplest absolute value equation, is y equals the absolute value of x. Okay, so those are kind of our basic equations or basic functions that we're going to be working with. Now, today what we're looking at is learning how different movements of a graph change the actual graph itself. So the first thing we're going to talk about is horizontal translations from left to right. Here, let's look at, this is a quadratic, a parabola right here. So we see this parabola. Now, if we look at what a translation to the left or to the right moves, what it does, if I just show you, I put one on here, the red one is the original, the blue one is the new one. As I move it to the right or to the left, it just simply slides back and forth. It doesn't change shape. It's not getting steeper or wider. It's not flipping upside down. It's just sliding back and forth. So that's what a translation does. So it just moves it to the left or to the right, but it doesn't change shape or size. So how we see a horizontal translation, it shows up like this. It's inside the parentheses, and when it's left, it's actually going to be x plus however many left. So like x plus 1. That means 1 left. So we're going to make a note to ourselves that when it's left, we use a plus sign. And the other thing I would make a note just right out here is that horizontal translations are when you add or subtract, you can abbreviate, and it's specifically inside. And I'll show you what I mean on inside in just a second, okay? So, if I wanted to see a horizontal translation right to, well, if left is adding, right is subtracting. And it feels backwards. To me, right feels like it should be adding, but it is subtracting. I'll show you why as we continue. So how I would show right to is by typing or writing x minus 2. That means to the right 2. Okay, so let's look at that on an equation. So when we talk about inside, what I mean by when I said that horizontal is inside, is it's inside the parentheses right here, okay? So like the plus 1 happened inside the parentheses. We'll see outside when we do vertical. So on an absolute value, when we mean inside, meaning you write plus or minus the number inside the absolute value bars. So let's write one. It's going to be y equals, inside the absolute value bars, we're going to have x plus 1. What that means is it's the absolute value translated or slid to the left 1 unit. So right 2 is also inside the absolute value bars, and it means you slid it to the right 2, and remember that right is minus, so we do minus 2. Okay, let's look at vertical translations, and then we're going to practice a couple times. So vertical translations, a vertical translation, if we go and look at this, the red's the original, the green is the new one. If I do a vertical translation up, it literally just slides it up. Now, it's not getting steeper or wider. Sometimes it'll look like that, but it's just moving up. The only reason it looks steeper is because you just can't see as much of it, but it doesn't change how wide it is. Same thing if I move it down, I'm just literally moving them up and down, okay? They're not changing anything about it. Let me show you one with an absolute value real quick, just so that you can also see that. So if I put just your most basic absolute value on here, give me just 1 second, there's an absolute value. So now if I try to do it with a translation, let's see here. then what it does is as I move it up and down, it literally just moves it up and down. That's a vertical translation, is a movement up or down. It doesn't change how steep it is. It doesn't change anything about it other than where it is. So how the vertical works is they are adding or subtracting. Add or subtract outside. And I'll show you what we mean by outside. So what we mean by that is down is minus, up is plus, just like they should be. They don't feel backwards to me on the vertical ones. So if I want to go down 3, I write f of x and then minus 3. Do you see how the minus 3 is outside of the parentheses? That's what we mean by outside. So if you wanted to write that as an absolute value, it'd be y equals the absolute value of x and then the minus 3. So the minus 3 occurs outside of the absolute value. So up is plus, so f of x plus 4 means up 4. So y equals the absolute value of x and then plus 4. So that means up. All right, reflections. What reflections do is they just take your graph and they flip it, okay? So they reflect it. I'll just draw a picture real quick. You don't have to write this down. But if you had a graph, so here's the x-axis and here's the y-axis. I'm going to make something kind of funky like a triangle. If you wanted to reflect this triangle over the y-axis, it would become something like this. Same shape, same size, it just flipped over it. If you wanted to do it over the x-axis, same thing. It's going to keep its shape and size. It's just going to reflect or flip over it. So that's what reflections are. So let's look at those. So a reflection, anytime you deal with a reflection, it's going to be negatives. So a reflection over the y-axis is going to be seen like this. It will have a negative inside the parentheses. So on the absolute value, it will have y equals the absolute value, and inside the absolute value, it'll have a negative x. So I'm just going to make a note to myself, negative inside, meaning inside the parentheses or inside the absolute value. So an x-axis reflection still uses a negative, but this one is outside, meaning outside the f of x. So on this one, you're going to see negative f of x. Or on an absolute value, it'll be negative absolute value of x. So it's not inside the absolute value, it's outside. Okay, let's talk about vertical stretches and shrinks. So vertical stretches, all right, when shrinks are done on the outside. Vertical is always outside of the parentheses or the absolute value, and vertical things are multiplied by the number. So first, let me just show you what a stretch or a shrink even looks like. So if I go back here and put my my quadratic on here, just look at something. If I stretch it vertically, it goes like this. Picture having just like a amount of silly putty or slime in your hands. If you pull it vertically, like pull it up and pull it down, it gets skinnier and longer. That's what this does. This is a stretch, a vertical stretch. Now, a vertical shrink, think about if you have your slime or silly putty in your hand and you squish it, you shrink it by pushing in from the top and the bottom. It squeezes out and it gets wider, and that's what this looks like. So it goes from this to wider. It flattens out. It's less steep. That's a vertical shrink. So shrinks get wider, stretches get steeper. Okay, so how we see that? If it's a vertical stretch by 5, then you multiply the 5 on the outside of the f of x. So like this. Or if it's an absolute value, you multiply 5 on the outside of the absolute value bars. So like this. So those both show a vertical stretch by 5. Now if it's a shrink, then you multiply the number on the outside, just like on the stretch. The only difference between how you tell if it's a stretch or a shrink is by the number. If this number, the 5 or whatever that number is greater than 1, then it is a stretch. If the number is between 0 and 1, then it is a shrink. So like 1/2 is a shrink, or 0.15, that's a number between 0 and 1, that's a shrink. So the number tells you if it's a stretch or a shrink. Okay, horizontal are the most confusing. Horizontal stretches and shrinks are also multiplying. And I'm going to put 1 over A, and I'll explain that in just a second. And they are, whoops, not outside, they are inside. All horizontal things are inside the parentheses or inside the absolute value bars. All vertical things are outside. So instead of using 7, you have to use the reciprocal, okay? I'm just going to write reciprocal. So you're going to use 1 over 7. So a horizontal stretch is going to be 1 over 7, and it occurs inside the parentheses, so like this, or inside the absolute value bars, like this. All right, I think of it in my head as not only is horizontal inside things, but also horizontal is always backwards. And what I mean by that is instead of using 7, we use 1/7. And like back at the very beginning, and when we went left 1, that feels like minus. Left just feels like minus, but it's opposite. It's plus 1. And so horizontal things are opposite of what you kind of feel like they should be. All right, in the horizontal shrink, you also use the reciprocal. So the reciprocal of 1/8 is 8. So let's use an 8. So it still happens inside the parentheses or inside the absolute value. So both of these show a horizontal shrink by 1/8. So if the original number, 7, is bigger than 1, that's a stretch. The original number 1/8 is between 0 and 1, that's a shrink. Same rules as vertical.